All right. In number 9, coffee is coming out the bottom of a leaking cone and dripping into a cylinder. So dVdt up here is negative, but dVdt right here is positive. dH, the height of this coffee, is negative, but down here, dH is positive. Letter A wants us to focus on this one. It tells you that the volume rate is 10, so we just got to make sure we understand that for the cone, dV is actually negative 10. But for the cylinder, dV is positive 10. So it's going out this one negative 10 inches cubed per minute, but it's going into this one positive. How fast is the level of the coffee pot rising? So we're looking for dH. And it says when the coffee in the filter is 5 inches deep. Well, what I can tell you is that the height inside this filter has nothing to do with what's going on here. And I'm going to prove it to you right now. So first of all, this is a cylinder. Its radius is 3. And then on top of that, the derivative of the radius is 0. Because at no time when this water drips will the radius ever be anything other than 3, no matter how high up this layer goes. Okay? So, the volume of a cylinder is pi r squared h. But because this is 3 and always 3, I can rewrite this formula as 9 pi h. And that's always going to be true because that derivative is 0. So if I derive it, I get dV dt equals 9 pi dH dt. And you can see that the actual height itself has no relationship with the rates. This is the cylinder, so the 10 is positive. And I'm looking for dH dt. So the answer exact is 10 divided by 9 pi as a quantity. But if I go ahead and round that 3 decimals, I end up with 0.354, and that would be in inches per minute. Now for B, I'm looking at the cone. How fast is the level of coffee falling? So now I'm looking for dH for the cone. Now if I go to the cone, this is the normal formula for the cone. You should know by now, after doing a cone 3 or 4 times, that there's always a ratio between the radius and the height. So if you look at this empty coffee filter, the radius is 3 and the height is 6. So that means that the radius is always half the height inside the cone. So I'm going to replace this for r. So I got v equals 1/3 pi. It'd be 1/2 h squared h. If I use some algebra there, I get 1/12 pi h cubed. If I differentiate it, I get dv dt equals 1/4 pi h squared dH dt. You can see now the height matters. And that is what it is. So now I want to go, because I'm in the filter now, right? The filter is negative 10. And it'd be 1/4 pi 5 squared dH dt. If I go ahead and use algebra to solve for that one, I end up with negative 0.509, and that is inches per minute.